Welcome to a lesson with Dr. Powell. Let's look at an example of Riemann sums when we have a table of values instead of a graph. And the table kind of restricts what we can use for our rectangles and measuring from where and what. So we really only will get an approximation. Notice that position is an antiderivative of velocity. So what if we were given velocity? Can we get position, or can we get the change of position? Let's suppose that the position starts right at 0. And let's suppose that this is an object that moves up and down only, up and down. Hence, see these negative velocities? That's because that's a speed heading downward. So if this is a table of data that we have, maybe right at time 0, the object is going upward at 2 meters per second. Then at 2 seconds, it's going upward still at 3 meters per second. At 4 seconds, it's only going upwards at 1 meter per second. At 6 seconds, it's going downward at -1, so it's going downward. So downward 1 meter per second downward, and then 2 meters per second downward at 8. So the question is, what is the approximate position at 8 seconds based upon the data on the table? Well, we can imagine really what we're doing is we're going to be approximating the actual position. The velocity itself, might look. So the velocity itself, let's see, if we were to think about it, has starts at 2, goes to 3, it drops to 1, and it drops further down. Maybe, velocity, something like this. And kind of what we're trying to do is we're trying to find the area under the curve, which represents the exact change of position. Now, we're going to be approximating that using rectangles. So really, we have intervals. It looks like, think about time, and we have an interval from 0, 2, 4, 6, 8. And what we're given some specific points on the curve at these different values. So right here, maybe we're at 2, then we're at a height of 3. Here we're at a height of 1. -1, and then we're down to -2. So how should we draw our rectangles? Well, we can get an estimate, a lower estimate, or an upper estimate, perhaps, as we do so. Why don't we just do a left-hand sum and then a right-hand sum and then take the average? Might be a good way to go. So left-hand, because the way the curve goes, maybe left-hand in one place is an overestimate, another place it's an overestimate, and vice versa for right. Why don't we just take the average of the two, left and right? So for left, it would look like our rectangles would look something like this. And then this one going down that way to the end of the end here, where the width looks like it's 2. So basically, we're just taking the heights, starting on the left, from right here, here. That's the same thing as just taking the sum of these right here and multiplying it by 2. Now, for the right-hand sum, it'd be similar. We just take the sum of what's over here, and then we multiply that by 2. Since we're taking an average, though, and we're multiplying by 2, and averaging just means divide by 2, may as well ignore the dividing by 2 business. The multiplication by 2 business, and just simply add this plus that. We could do that. In fact, if you notice, these guys right here will be doubled, and these guys will just be added on their own. Notice they cancel. So really, it's just the sum of this doubled, which ends up just being 6. So it looks like the position at 8 seconds will be at 6 meters above position 0. So approximately 6 meters using our technique. Now I kind of talked a little bit quickly through that, so let's actually work through it in a little bit more slow motion. All right, so let's take a look at what we've done here. This is a left-hand sum. Let's just add this up. This would be, so this is a height of 2 and a width of 2, so that would be 4. Here that would be 2 times 3, so that would be 6. Here this would be 2 times 1, so that would just be 2. This would be negative 2. We add this up, we end up getting 10. So the left is equal to 10. Now let's take a look at the right. So for the right, let's just erase these here because we're going to be getting our rectangles a little differently here. All right, so for our right, looks like we have, we're going all the way up to 3, so 3 times 2. So this rectangle is really 6. Here we're at 1 times 2, so we're at 2. Over here, basically our rectangle's just moved over. We're going down to negative 1 times 2, so that would be an area of negative 2. And then right here, we go down to negative 2. Negative 2 times 2 is a negative 4. Notice we have negative 6, so it's 2. So the right is 2. Then if we take the average of 10 and 2, we end up getting 6 as we had noticed. So the position is just 6 meters above position 0. And we got that just by looking at a table of data for the velocity or the rate of change of position. Thanks for watching.